We're going to talk about how we can identify ionic compounds. Okay, so the ionic compounds, of course, are made up of a positive ion and a negative ion. And the procedure is, first of all, you try and test, you run a batch of tests to identify what the positive ion is. So, for example, saying if we do a test and we find out the positive ion is lithium, Li+, test for 9 different positive ions there, got 9 there. And then we run a test on the negative ions. We've got 5 different negative ions we can test for here. And let's say we find out that the negative ion is the carbonate ion. So we know we have now identified our compound. It is lithium carbonate, and it would have to be Li2 CO3 because the Li is only 1 plus and carbonate is 2 minus. So we know our compound was lithium carbonate. Or for example, let's say we run our batch of tests and we find out that we have got ion 2, Fe2 plus ion, and the negative ions we find out we've got iodide. So we'd know that we had got ion 2 iodide. That would be FeI2 because ion is 2 plus and iodide is only 1 minus. So you get the idea. We can identify the compounds by identifying the positive ion first and the negative ion. And there's a sort of efficiency there because if you think we have got 9 positive ions we can test for, and we've got 5 negative ions, so that gives us a total of 45 compounds we can test for. Whereas the number of tests we need to detect them, we need 9 separate tests for the positive and 5 for the negative. So we only need 14 tests to give us identify potentially 45 different compounds. Right, so let's talk about those individual tests for those ions. Right, so first of all, let's have a look here. See these ones where I put a color. So for the positive ions, so these are flame tests. So what you do is you put a small amount of the compound in a blue Bunsen flame and a roaring Bunsen flame, and depending on what compound you've got there, it will impart a certain color to the flame. So if you get any sodium ions, it will look orange. Potassium will look lilac. Lithium is bright crimson color. Calcium gives you a sort of less intense brick red color, and copper gives you a green color. Okay, so that's how you can identify all of those. The other positive ions, the magnesium, aluminium, and the 2 ions, they don't give you any flame color at all. So you, if you put those in a Bunsen flame, you get no flame color. Right, now the other bank of tests to identify positive ions is you add sodium hydroxide solution to the solution that you're interested in. Okay, so you can detect all of these actually, including copper, which I haven't done there, and you'll get a different precipitate depending on which ion you've got. It'll be a different color. Copper conveniently will give us a green precipitate. Sort of a palish green. Calcium will give us a white precipitate. So you can sort of double check if you've got calcium. Does it give you a brick red flame color, and does it give you a white precipitate with sodium hydroxide solution? Magnesium also gives us a white precipitate, so that can be confused with calcium. And aluminium also gives us a white precipitate, but that one is a bit special because when you add excess, it says there, you add a little bit more sodium hydroxide, the white precipitate will redissolve. So aluminium is quite easy to identify in that way. Fe2 gives you dark green precipitate, much darker than the color you get with copper, and iron 2 gives you a brown precipitate. So they're all quite easy to identify in that way. The one that's a bit tricky is distinguishing between, of course, calcium and magnesium, because they both give you a white precipitate. But then you can resolve that by doing a flame test. Calcium will give you a brick red flame test, and magnesium, no flame test, no flame color at all. So that's the test for the positive ions. For the negative ions, let's look up here. Right. So, right, the halogen, the halide ions, these three here, you test for them by adding silver nitrate solution. Right, strictly speaking, you should acidify it as well with a bit of nitric acid. Now, if you've got any chloride ions present, you get a white precipitate. That white precipitate is silver chloride, which is insoluble. If you've got any bromide ions present, you're going to get a cream precipitate of silver bromide, which is also insoluble. And if you've got any iodide ions present, you're going to get a yellow precipitate of silver iodide, and that's insoluble. Okay, so the testing for the halide ions is relatively straightforward. You add silver nitrate. Sulfate ions, right, there's a special test for that. You add barium chloride solution, and if you've got any sulfate ions present, you're going to get a white precipitate, because you're going to form, if there's any sulfate at all present, you'll form barium sulfate, which is very, very insoluble, and that will form a white precipitate. So that's fairly easy to test for. Strictly speaking, again, you should acidify the barium chloride. Obviously, you can't acidify it with sulfuric acid because that contains sulfate ions, so you usually acidify with HCl, or you can acidify with nitric acid. The carbonate test, well, that's a little bit different, and you add acid, and if you add acid to any carbonate, you will get CO2 gas released, so you'll see fizzing. And to confirm that that gas that's been released during the fizzing is CO2, you should really bubble through lime water. And of course that will turn the lime water cloudy. So that is the bank of tests that you run to identify those compounds. It's quite straightforward really, but there's quite a lot of memory work there, learning all those colors and things. And also precipitation reactions, they can be a little bit difficult to understand, so there is a video on precipitation reactions if you want to watch that, just to make sure you understand what's going on there.